All right, so this is the part 2 of the October-November 2020 paper 2 variant 2. Okay, so I'm going to be solving question number 6 onwards. In the last video I solved to question number 5. Okay, so yeah. Okay, this is a functions question, which is, well, it's likely that this topic comes in paper 1, but there are some topics about which you can't really say for sure whether they're going to come in paper 1, paper 2. So this is perhaps one of those topics. Okay, so either way, it's very simple. Okay, so in the first part you have to find f of minus 5. So that you can find by simply plugging in minus 5 in place of x. So 4 2 minus 5. Okay, so 2 minus minus 5 is equal to positive 7. So 4 times 7 is equals to 28. And there you go. Easy does it. Pretty simple. Then it says solve the inequality. F of x is greater than 3. Okay, so first things first is that I need to write f of x, which is 4 times 2 minus x, and then put a greater than 3 sign. Okay, so I have to solve for the value of x. Actually, I have to solve for x. Okay. So 4 times 2 is 8, minus 4x is greater than 3. So let's shift the positive 8 on the right hand side. So minus 4x is greater than 3 minus 8. Okay, so if you want, you can, I'm sorry about my flu. So yeah, if you want, you can do 3 minus 8, so that's minus 5. Okay, now with inequality, there's something that you got to watch out for, is that if this were an equation, you'd simply cross out the two negatives, all right? With an inequality, when you do that, you're still allowed to do that, but when you do that, you got to watch out is that one thing that you got to watch out for is that the inequality sign flips. Okay, so 4x is now less than 5. So now if you solve for the value of x, so that's equal to less than 5.4. So there you have it, x is less than 5.4, or if since this is paper 2, you can give this in decimal also, you'll still get the mark. Okay, and then it says find f inverse of x. Okay, so that also shouldn't be too hard. F inverse of x, so remember the 3 steps that you have to find the inverse. So first of all, f of x, I'm going to write the expanded version, so which is 8 minus 4x. Okay, so I'm going to set this equal to y equals to 8 minus 4x. Then I'm going to try and make x the subject, so 4x equals to 8 minus y, x is equals to 8 minus y upon 4, and then the final step, which is that you replace x with f inverse of x and y with x, so 8 minus x upon 4. So there you have it, 8 minus x upon 4 is your final answer. Alright, now we're at part D, which says f of p is equals to g of 2p plus 1. Find the value of p. Alright, so first things first, let me just write down what f of x is. So f of x is 8 minus 4x. Let me also write down what g of x is. So g of x is 7 minus 3x upon 5. 7 minus 3x upon 5. Okay, so f of p basically means that I'm going to replace x with p. So that shouldn't be too hard. 8 minus 4p. And since this is equals to g of 2p plus 1, this means that I'm going to replace x in function g with 2p plus 1. So this is equal to 7 minus 3 into 2p plus 1 upon 5. Okay. Now, in order to solve this, you just have to cross multiply LCM and stuff like that to get the final answer. Okay, so let's let's do this step by step. So first thing I need to do is, actually there are a lot of ways through which you can solve this, and in fact here's what I'm going to do. I'm going to try and avoid the LCM. Okay, so I'm going to shift 7 on the left hand side. So when I do that, it gets subtracted, and 8 minus 7 is 1. So 1 minus 4p is equals to minus 3 times 2p plus 1 over 5. Okay, now I can cross multiply, and when I do that, so this becomes 5 minus 20p is equals to, and then at the same time I can open up these brackets, minus 6p minus 3. Okay, now let's solve for the value of p. So I'm going to bring the minus 3 on this side. So minus 3, when we bring it here, becomes positive 3. So 5 plus 3 is equals to 8. So, and minus 6p plus 20p. Okay, so 8 is equals to minus 6 plus 20 is positive 14p. Let's write this nicely. So 14p is equals to 8. P is equals to 8 upon 14. And if you simplify this using the table of 2, so P is equals to 4 upon 7, which is the correct answer. So there you go, easy does it. Okay, so that was question number 6. Let's do question number 7. This is a polygon question. So when you're preparing for your October-November session, I would suggest that, these little topics, functions, polygons, don't neglect them entirely, okay? But because as you can see, they can come in paper 2 also. So it says the diagram shows part of an n-sided regular polygon A, B, C, D, E, F, G, H. Okay, so it's a regular polygon. DCF is equals to EFC, which is equal to 24. All right, we can see that also. And then it says find the value of n. Okay, so because it's a regular polygon, so that basically means that okay, so there are two ways to solve this question. I'm gonna go with the easier way first, okay, and then I'll tell you what's the other way to do it. So if you make a line here, okay, so this line is going to be parallel to this line, okay, which basically means that this angle right here is equal to what? Is equal to 24 degrees. Now this entire angle is equal to 180 degrees because it's a straight line. So 180 minus 24 will not give me the final answer, but it will get me closer to the final answer, which is equal to 156. So basically, here's what we're doing. We're looking for a regular polygon which has each interior angle which is equal to 156 degrees. Okay, so is there a formula for that? There is. Okay, the formula is that each interior angle is basically equal to n minus 2 times 180 upon n, which is equal to 156. Now since this is paper 2, this shouldn't be too difficult. 180n minus 360 is equals to 156n. If you bring 156n on the left hand side, so that becomes 24n, and if you shift 360 on the right hand side, so equals to 360. Basically I'm just solving this equation. So n is equals to 360 divided by 24, which is equal to 15 degrees. Okay, now sorry, not 15 degrees, 15 sides. Okay, now the difficult way of doing this, sorry, the easier way, this was the difficult way. Let me just make some room here. Yeah, again, sorry about my flu. So then easier way to do this would have been to use the exterior angle. Now this 24 that I'm highlighting right now is basically the exterior angle, okay, and the formula for calculating each exterior angle is a lot easier than the formula for calculating each interior angle. So the formula for each interior angle is basically exterior angle, sorry, 360 upon n. Okay, so I'll write it over here, each exterior angle. Okay, so 360 divided by n is equal to each exterior angle, which is 24, and then again if you solve this equation you get the same answer, n is equals to 15. So there you go. This will save you a lot of time, and yeah, will save you a lot of time basically, but either way you're gonna get full marks. Okay, so n is equals to 15, that's that. And then you have HFG. All right, HFG basically means that HFG, okay, so let's make a triangle out of it first. All right, so basically the question is asking you to work out this angle. Okay, now this, something tells me that this is going to be an isosceles triangle. Okay, now am I guessing or am I assuming that it's an isosceles triangle? No. Okay, reason for that is because since this is part of a regular polygon, FG and GH will be the same. And another thing is that the interior angle, each interior angle of this polygon is going to be 156. So if we just focus on the triangle that I'm highlighting as I speak, so this is an isosceles triangle, and being a triangle basically means that the sum of interior angles is going to be 180. So basically 156 plus x equals to 180. 2x is equals to 20, not n, sorry, 2x is equals to 24, since that's what 180 minus 56 is. X is equals to 24 divided by 2, which is equal to 12, and that is the correct answer. There you go, 12 degrees. Simple. All right, now we come to part B, which by the looks of it is related to similar triangles. Yeah, okay. So PQRS is a parallelogram. All right, that's very helpful. TU and SQ intersect at X. Okay, we can see that. And TU is parallel to QR. All right. TQ is to PT are in the ratio is the same as UR is to SU. Okay, so TQ is to PT are in the same ratio as UR and SU. Okay, show that triangle PQS is similar to triangle TQX. Okay, so let me just highlight them. PQX, I'm going to be highlighting this with green. There you go. And TQX, all right, TQX. Okay, so this shouldn't be too hard. So first of all, they have a common angle. Okay, so let's start with that, and that is basically Q. So so 3 marks. I need to write 3 logical statements. Okay, so I'm going to start with this, that PQS is equal to angle TQX, and that is because it's a common angle. Okay, so that's that. Then this angle is going to be equal to this angle. Reason for that is corresponding angles. So here's what I'm going to write. I'm going to write QTX is equal to angle QPS. Yeah. Reason is again pretty simple. I just mentioned it, and that is corresponding angles. All right, so far so good. Then for the very same reason, this angle right here is going to be equal to this angle. Okay, so this means that angle QXT is equal to angle QSP. All right, so step by step, easy does it, no need to rush into it, and the reason is the same, corresponding angles. All right, so there you have it, 3 marks in the bag, nothing to worry about. Find the ratio SX is to SQ. All right, SX is to SQ. Okay, now, so as according to the question, as per the question, TQ and PT are in the same ratio as UR and SU, which basically means which is 1:2. Okay, so let's take a step back. TQ is to PT. Okay, so that basically means that if this is one part, this is 2 parts, which tells me that all of this is basically split into 3 parts. Okay, so that basically means that these triangles are similar in the ratio 1:2. What triangles? The triangles that the question just mentioned, PQS and TQX. Yeah. So since they're similar in the ratio 1:3, okay, so here's what I'm trying to say. So this length, which is QX, and this length, which is QS, they will also be in the ratio 1:3, which basically means that SX or XX will be 2 parts of the 3. Okay, now let's see what the question is asking for. The question is asking for SX is to XQ. So the answer to that, we now have it, is that 2:3. So in short, what you have to remember is this, that when 2 triangles are similar, all their lengths, all the corresponding lengths are similar in the same ratio. Okay, so that's exactly the concept that I've applied here also. Then it says find the ratio of the area of triangle TQX is to area of parallelogram PQRS. Okay, so TQX, there you are. Okay, interesting. Right, so what I should do ideally is I should just redraw the entire thing. Okay, so yeah, this looks good. There you go. And anything that I missed? Yeah. Okay, so basically the 2 similar triangles were these 2, all right? And they were similar in the ratio 1:3. Okay, not 1:2, 1:3. So that basically means that if you remember the formula for when 2 objects are similar, the ratio of their areas are basically the square of the ratio of their lengths. Okay, so here's the thing. This is 1 part, okay, and all of this is 3 parts. So that means if I were to work out their areas, it will be A1 upon A2 is equals to 1/3 the whole thing square, which means that the ratio of their areas will simply be 1:9. But don't get carried away. That's not your final answer. This basically means that if the area of this little triangle is 1 part, okay, the area of this entire triangle, the one that I'm highlighting now in green, will be 9. Okay, will be 9 times of the area of the smaller triangle. Okay, so what is that? How is that going to help me calculate the area of the entire parallelogram? Now, if the area of this triangle, the one that I've highlighted in green, is 9, and this triangle is basically half of the parallelogram, so that means the area of the parallelogram will be 9 plus 9, which is equal to 18. So that means area of TQX 1 is to area of parallelogram PQRS, which is equal to 1:18. Now, there's something that I always tell my students over here is that the formula A1 upon A2 equals to L1 upon L2 the whole thing square, or even V1 upon V2 equals to L1 upon L2 the whole thing square, can only be applied when 2 objects are similar. Okay, it's like, there's something that I always say, and it helps my students remember, is that you can compare an apple with an apple. An apple can be similar to an apple, it cannot be similar to an orange. Okay, so that's just something that maybe will help you remember that, apples with apples and oranges with oranges. So the reason why I'm saying this is because what a lot of students do is they don't realize that the 2 objects are not similar. In fact, they're completely different shapes, like one is a triangle and one is a quadrilateral, and they end up using this formula. So that doesn't work. For this formula to work, the 2 objects, not only do they need to be of the same shape, but they also need to be similar. Okay, so yeah, remember that. Okay, So here's question number 8, which is vectors and coordinate geometry. Yeah. So it starts off with, it has a bit of both, okay? So h is the point, minus 7 comma 4, and hj is 10 comma minus 6. Calculate the magnitude. So what do you do when you have a vector and you want to work out its magnitude? You simply take the square root, and you do the sum the square of their individual components x and y, and then you take the square root of it. So hj is equals to 10 square plus 6 square, 136. So square root of 136 is equals to 11.66. So let's log this at 11.7. There you go. 11.7 is our final answer. Let's switch to another color. Given that hk is equals to 3 times of hj, find the coordinates of the point k. Okay, so hk is equals to 3 times of hj. So that's something that we can instantly work out. 3 times of 10 and minus 6. So hk is equal to 30 and minus 18. Okay, now we have to work out the coordinates of k, which in vector terms basically means the position vector, okay, ok. So our job is now to break up hk, which somehow includes the position vector of k. So how do we do that? Okay, we can do that pretty simple. We can do that very simply, and we can rewrite hk as, if you remember the subtraction rule, hk can be written as ok minus oh. Okay, so ok minus oh. I have a detailed video on vectors, you guys can go check it out. So I'm going to rewrite hk as ok. In fact, I have a detailed playlist of vectors, so you guys should check it out. Ok minus oh, which is equal to hk, is basically equal to 30 minus 80. Now there are two things that we don't know. There are two things that are not known here. One of them is given to us in the question, and that is the coordinates of the point h, which are minus 7 comma 4. So I'm simply going to replace that with minus 7 comma 4. All right, be careful of the signs. Is equals to 30 and minus 18. Let's write this nicely. Ok is equals to 30 minus 18 plus, now you don't have to change the sign of the components, it's just the sign in between that changes. Okay, so what I'm trying to say is this, that negative 7 will remain negative 7 and positive 4 will remain positive 4. So ok is equals to 30 minus 7, which is equal to 23, minus 18 plus 4, which is equal to minus 14. Yep, that's the correct answer, 23 minus 14. Okay, now part B. Now this is a genuine vectors question. It says the diagram shows a parallelogram OBCE. Alright, OA is equals to P, OE is equals to Q. Alright, that's great. AD is parallel to OE, AD is parallel to OE. Alright, which basically, and in fact, in this case, it's not just going to be parallel, they're going to be parallel and equal. So this instantly is going to be equal to Q. And all of BC will also be equal to Q. So I'm going to mark it over here, so just to save some time. Okay, and then AD is parallel to OE. Yeah, I just read that. And OA is to AB are in the ratio 1 is to 3. So OA and AB are in the ratio 1 is to 3. So this means that OA, which is one part, is equal to 3, is equal to P. So AB is going to be 3 times of OA. So that means AB, I can work it out instantly, that it's going to be equal to 3P. Okay, and then x is a point on BC such that bx is to xc are in the ratio 3 is to 2. Okay, so here is where you got to be careful. So they're in the ratio 3 is to 2. Now since we don't know what bx is equal to individually and we don't know what xc is equal to, however, what we do know is the total, which is b to c. And b to c is split into how many parts? It's split into 5 parts. And bx takes 3 of those parts and xc takes 2 of those parts. So that means bx is basically going to be equal to 3/5 of the total, which means it's going to be equal to 3/5 of Q, and XC is going to be equal to 2/5 of the total, which means 2/5 of Q. Okay, so yeah, this is something I always encourage my students to work it out immediately because it's going to save you some time. Okay, so OC. Now OC is going to be pretty simple. We're going to go from O to E and then from E to C. Or if you're thinking O to B and then from B to C, that's also perfectly all right. So O to B is going to be B plus 3P, so that's going to be 4P, right? Remember, all of this is going to be 4P. And then you're going to go from B to C, which is Q. Simple. And then AX, 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 AX. Okay, so for AX, we're going to go from A to B. All right, let me just write it over here, AB, and then we're going to go from B to X. Now we have all of that. Okay, that's why I wanted to I told you guys to work this out immediately because it's going to save you some time. So AB is equal to 4p, and then BX is equal to 3/5 of Q. So let's write this down, 4p plus 3/5 of Q. And then let's work out EX. Okay, so with EX, you got to be careful with the signs. Okay, so you're going to go from E to C, which is 4p, E to C, which is 4p, all right? And then plus, now you're going from C to X. So that's going to be 2/5 of Q, but since you're going in the opposite direction, so it's going to be minus. So plus minus 2/5 of Q. So this is equal to 4p minus 2/5Q. All right, so far so good. Question number 9, trigonometry, further trigonometry, guaranteed it's going to come in paper 2 for sure. In triangle ABC, AC is equals to 6.4, BC is equals to 9.5, BAC is equals to 79 degrees. All right, what do we have to work out? We have to work out angle ABC. So we have two sides and non-included angle. Sine rule, simple. So sine B or ABC, you can write the entire thing if you want, over 6.4 equals to sine 79 over 9.5. This is something that I should have mentioned at the beginning, but since I did not, I'll mention it now, is that make sure that before you start your paper that you reset your calculator, especially if you're an advanced student. Even if you're not, it's possible that somebody may have borrowed your calculator. Some advanced student, they might have changed the mode. So make sure that you guys reset your calculator before you start math paper 2. So the answer for this turns out to be 42.2 degrees. No, wait a minute. Sine 79, let me just do that again. Divide by 9.5 into 6.4, sine inverse of the answer. So 41 point, this turns out to be 41.4 degrees. Yep, that's correct. Okay, calculate the area. Okay, so now if you want to work out the area, so it shouldn't be too hard, because to work out the area you need two sides and an included angle. So although we do have two sides, but we don't have the included angle, so we can always work that out. So I'm going to take the angle that I just worked out, which is 41.4 right here. I'm going to add 79 to it, and I'm going to subtract 180 from the answer. I'm going to subtract the answer from 180, in fact. So that gives me 59.6 degrees. So now I have two sides and an included angle, so I can work out the area using the formula half equals to AB sine C. So two sides, 9.5 and 6.4. 9.5 into 6.4 into sine 59.6. So let's work this out. 0.5 into 9.5 into 6.4 into sine of the last answer. So that gives me 26.2. Corrected three significant figures, centimeters squared. Okay, now we're at part B. So this is like a 3D trigonometry question. Okay, again, very likely to come in paper 2. So the same triangle ABC forms the horizontal base of a pyramid ABCD. So which triangle? It's talking about this triangle. No, wait, it's not talking about this triangle. Okay, anyway, let's treat it independently. BD is equals to 9.8, all right, and what do we have next? CD is equals to 8.2, BAD is equals to CAD, which is equal to 90 degrees. We can see that. Calculate angle BDC. Okay, so BDC, the first thing you should do whenever you're doing a question like this is that you should first decide what triangle you're going to use in order to calculate the length that is asked of you. Okay, so I'm going to use triangle BDC. That's a no-brainer. Okay, so and I always encourage my students to draw it separately, so that they don't get confused with everything else that you have in the question. So you have, doesn't have to be very accurate. 9.8, 9.5, and 8.2. Okay, so since you have all three lengths and you're asked to work out an angle, which is this angle, BDC, so that means I'm going to use cosine rule. And how do you use cosine rule? Like this. Cos of BDC is equal to, so the two included lengths are going to be added, of course, after you've squared them, and the length that is opposite the angle which you're trying to work out is going to be subtracted, and then the two included lengths again are going to be multiplied by 2. Okay, so I'm going to do this in my calculator, and then when I have the answer, I'm simply going to do cos inverse of the answer. Okay, but let me show you how you're supposed to do it. Okay, so it's best that you make a fraction and punch this in as it is. 9.8 squared plus 8.2 squared minus 9.5 squared over 2 into 9.8 into 9.8 into 8.2. Okay, let me show you how I've done this. Okay, hope you guys can see it. and then equals to cos inverse of the answer. So that turns out to be 62.97. Now remember, with angles are always given correct to one decimal place. Okay, so 62.97 will be rounded off to 63.0 degrees. Okay, so yeah, calculate the angle of elevation of D from C. So D from C. So again, we need to decide what triangle we're going to use, and this time we're going to use B. Okay, so we don't really have a that point isn't really called anything, so I'm just going to call it P. Okay, so that it's easy for us to refer to it. So it's basically, I'm going to be using DPC or CPD, whatever it is that you wish to call it. And again, I'll encourage you guys to draw this separately. So here's what I'm doing. It'll hardly take you guys 30 seconds, but you know, this way your chances of being confused will go down. Okay. There you go. Okay, so here's C, here's B, and here's D. Okay, so we have the hypotenuse, which is 8.2, is it? Yeah, and we have the adjacent, which is 6.4. So this is the angle that we need to work out. So we're going to use cos. So cos of C is going to be equal to adjacent over hypotenuse. So I'm going to do 6.4 divided by 8.2 and then cos inverse of the answer, which turns out to be 38.69. Okay, and then since we have a rule that angles are going to be given correct to one decimal place, so we'll log this at 38.7 degrees. 38.7 degrees. So there you go. Pretty simple. Okay, so that was that, and we have another question. That's question number 10, which is also the last question. All right, so that shouldn't be too hard. Okay, so this is a quadratic equations. Again, it's one topic that you can be absolutely sure it will come in paper 2 one way or another. So a meter drives 40 kilometers to work. A meter takes X minutes to drive the first 30 kilometers of the journey. Show that her average speed for the first 30 kilometers of the journey is 1800 over X. Okay, so there's a catch in the question, and is that, you know, you have X minutes, but the speed the question's asking for is in kilometers per hour. Okay, and as we know that speed is basically equal to distance upon time. So for the first 30 kilometers, obviously the distance is going to be 30. The time is going to be X, but since X is in minutes, that means we got to convert this into hours by dividing it by 60. So this turns into 30 divided by X upon 60, which then turns into 30 into 60 over X, which basically turns into 1800 over X, exactly what the question wanted us to show. A meter's average speed in kilometers per hour for the final 10 kilometers of the journey is 600 over X minus 25. All right. Her average speed for the first 30 kilometers of the journey is 8 kilometers per hour slower. Okay, so let's highlight what we think is important. Average speed for the first 30 kilometers per hour is 8 kilometers per hour slower than the average speed for the final 10 kilometers per hour. Okay, so basically what we need to do is we need to translate this from English to math. Okay, we need to make an equation out of this. But again, don't jump into, again, not the kind of question which needs to have an head-on approach. You know, slow down, see what the question is saying, try and see step by step what you can do in order to make an equation out of this. So basically, her average speed, okay, for the 30 kilometers per hour, for the first 30 kilometers per hour is means equals to sign, 8 kilometers per hour slower basically means less, which is minus, then her average speed for the final 10 kilometers per hour. So this is how you're going to make an equation out of it. So her average speed for the first 30 kilometers per hour, we worked it out, was 1800 over X. Her average speed for the final 10 kilometers is 600 over X minus 25 and then minus 8. Now, if we've done this correctly, when we cross multiply and take out the LCM, whatever it is that we have to do, and boil it down to, and when this boils down to a quadratic equation, this is what it should look like if we've done this correctly. Okay, so I'm hoping that we've done this correctly. So if you want, you can take out the LCM immediately. I, however, would like that I shift minus 8 on the left hand side, and then we have 600 over X minus 25 as it is, and bring the 1800 over X on the right hand side, which is why it becomes negative. Okay, so 8 is equals to, the LCM is going to be X squared minus 25X. 600 is going to be multiplied by X, so 600X minus 1800, is going to be multiplied by x minus 25. Now the reason why I didn't multiply this immediately is because I can so that I could show you something very important, is that you got to be careful of the sign also. So this is going to be minus 1800x, and then minus minus is going to get positive. So 1800 into 25 is equals to 45,000 over x square minus 25x. Okay, so now let's cross multiply. So this will become 8x square. 25 times 8 is 200. Yeah, it is. Minus 200x is equal to 600 minus 1800 is going to be minus 1200x, and then plus 45,000 as it is. Let's shift everything on the left hand side. So 8x square, and while we're at it, simplify it also. Minus 200 plus 1200 is going to become 1000x minus 45,000. Okay, now this is nowhere near what the question wants us to show, and that's because we need to take common, and what we need to take common is 8. So this is going to become x square. 1000 divided by 8 is equals to 125, so plus 125x, and then 45,000 divided by 8, which should be 5,625, and that's what it is. Minus 5,625 equals to 0. So there you go, x square plus 125x minus 5,625 equals to 0, and you get how many marks? 3 marks for this. Okay, solve the equation. Now if you want to solve this, you can use the quadratic formula. X is equals to minus b plus minus square root of b square minus 4ac upon 2a. It's best to write down a, b and c separately for yourself. So a is 1, b is 125, and c is minus 5,625. Okay, so to save some time, I'm going to use the quadratic formula in your calculator. I've made a video on this. I think it's on my Instagram. Yeah, make sure to check it out. So a is 1, b is 125, minus 5,625. So one value is 35.1. The other value is minus 160.1. And since it says, make sure, I didn't read that the question was actually asking it correct to 1 decimal place. I just got lucky and got away with it. But whenever you're doing a question like this, make sure that you read, because sometimes it's going to be correct to 2 decimal places, sometimes 3. It's always best that you read what the question's asking for. Okay, then I think, let me just check the answers so far. Yep, so far so good. And I think we're at the last part of the very last question. It takes Amira 25 minutes less to drive the final 10 kilometers than it takes for the first 30 kilometers. Calculate Amira's average journey in kilometers per hour for the whole, average speed, in kilometers per hour for the whole journey. Okay, so for the whole journey, it's going to be total distance traveled upon the total time taken, and that's going to give you the average speed. Now we know very well what the total distance is. That's 30. So average speed, we have the total distance, which is, sorry, that's not 30. I think I said 30. That's 40. Is it? Yeah, it's 40. Okay, so 40 divided by total time. Okay, so with time, you got to be careful. Now, since you worked out the value of x, which is 35.1, now you got to be careful is that this is basically in, there are two values, 35.1 and minus 160.1. So one thing that you need to be careful of is that you're going to use the positive value. Okay, so if you go back, according to the question, it takes her x minutes to drive the first 30 kilometers per hour. So that means when she's driving the first 30 kilometers, okay, it takes her x minutes, which is 35.1. And then when she's driving the final 10 kilometers, okay, remember this is minutes, all right, it takes her 25 minutes less. So that means when she's driving the final 10 kilometers, it's going to take her 25 minutes less than 35.1. Okay, so that's what I'm going to do. 35.1 minus 25. So now I have 10.1 minutes. So altogether, it takes her 35 plus, let's just use a calculator. So 35.1 plus 10.1. So it takes her 45.2 minutes for the entire journey. Okay, so then I'm gonna, I already have the total distance. I'm gonna divide this by 45.2, and then since this is in minutes, I want to give the final answer in hours, so I'm gonna divide this by 60. So 40 divided by 45.2 over 60. Let's see what we get. We get 53.09, which correct to 3 significant figures is going to be 53.1 kilometers per hour. So yeah, with this we have finally completed the paper. Let me know what you guys think of the solution, and this will definitely be a good way for you guys to prepare for either the mini series or for October November. So for now I'm going to be focusing on paper 2. So if you're appearing in October November, you can prepare for paper 2, but you got to wait for paper 1. And once the students who are appearing for the mini series in July August, once they're done, then we can start solving paper 1 also. So yeah, that's all for this video. I'll see you guys in the next one. Until then, take care. Bye bye.